Hello everyone, welcome to solve this nice math Olympiad algebra problem. So here we have a square root of c is equals to minus c, and we solve this problem for all the values of c. So here first we need to find all the roots of this equation, and at the last we will be verify that which of the roots are solution and which of the roots are extraneous root. Further, we solve this problem for two methods. I hope so you like both of these two methods, but if you have any other method in your mind, so please don't hesitate to write this method into the comment section. And now we move toward the solution of this problem from first method. And here we first move this minus c into the left hand side, and it will be written as square root of c plus c, and this whole equation is equals to 0. And now here we know about a nice rule of radicals. So if you have a number a, we write this a as in the form of square root of a multiplied by square root of a. So according to this rule of radicals, we write this term c as in this form. So this will be written as square root of c, plus we write this c as in the form of square root of c multiplied by square root of c, and this whole equation is equals to 0. And in the next step, you see here both of these two terms involve square root of c. We take common square root of c from here, and when we take common square root of c, we get the remaining values are 1 plus square root of c, and this whole equation is equals to 0. And now in the next step, we divide this equation into the two cases. The first case is we write square root of c equals to 0, and the second case is we write 1 plus square root of c is equals to 0. So here for the values of c, we need to take squaring on both of the sides. So when we apply squaring, it will be written as square root of c square equals to 0 square, and here we move plus 1 to the right hand side, and it will become square root of c is equals to minus 1. And again for the values of c, we need them again squaring on in this case also. So it will be written as square root of c whole square equals to minus 1 whole square. And further we have this 2 and square root are gone, and we get here c is equals to 0 square, and 0 square becomes 0. So here we get only one. uh, Here we get the first root of the given equation, and that is c equals to 0, and from here you see that this 2 and square root are gone, and we get here c is equals to, this is minus 1 square, and we know about that minus 1 square becomes plus 1. So this is the second root of the given equation. So in the first method we obtain these are the two roots of the given equation, and now in the next step we need to verify that is these roots be the solution or is these roots be the extraneous root. So for verification of these roots, we need to copy down given question statement. Here it is square root of c is equals to minus c, and in this side we will be verify c is equals to 0, and in this side we will be verify c is equals to plus 1. So here we substitute c equals to 0 on both of the sides of the above equation, and it will be written as square root of 0 is equals to minus 0, and we know about that square root of 0 becomes 0 equals to 0. So this shows that both of the sides are equal, and if both of the sides are equal, this concludes that the value of c equals to 0 is satisfied our given question statement. So here in the same pattern, we verify the second value of c, and when we put c equals to 1 on both of the sides, it will be written as square root of 1 is equals to minus 1. And we again see that a square root of 1 becomes 1 equals to minus 1. So you see here both of the sides are not equal, or in other words, we say that it is not possible case. It is not possible that 1 is equals to minus 1. So these are not equal, and if these are not equal, this means that the value of c equals to 1 is not satisfied our given question statement. So we finally conclude about that c equals to 1 be the extraneous root of the given equation. Okay. This is the extraneous root because it does not satisfy our given question statement, and c equals to 0 is satisfied our given question statement. So we called that c equals to 0 be the only one solution of the given equation. So this is our final answer which we get here from first method, and now we again solve this problem from second method. So for second method, we need to copy down given question statement. Here it is square root of c is equals to minus c. This is our given question statement. And here in the second method, we directly take squaring on both of the sides. So when we apply squaring on both of the sides, it will be written as a square root of c whole square equals to minus c whole square. And further we have these two and square root are gone, and we get here c is equals to, this is minus c whole square, and minus c square becomes plus c square. And further in the next step we move this plus c from left hand side to the right hand side, and it will becomes, this is c square and this is positive c becomes negative c, and this whole equation is equals to 0. And in the next step you see here both of these two terms involve c, so that we take common c from here, and when we take common c we get the remaining values are c minus 1 equals to 0. And now we divide this equation into the two cases. The first case is we write c equals to 0, and the second case is we write c minus 1 is equals to 0. So this is the first root of the given equation, and from here we get the value of c is equals to plus 1, and this is the second root of the given equation. So in the second method you again see here we get both are the same roots of the given equation, but in the first method we already verified that c equals to 1 is not satisfied our given question statement. So we call that c equals to 1 be the extraneous root of the given equation, and c equals to 0 be the solution of the given equation, because c equals to 0 be the only value which is satisfied our given question statement. So this is our final answer of this question, and thank you so much for watching this video. Please subscribe to my channel for more exciting videos.